What is a quadratic equation? A quadratic equation is a second-degree polynomial equation in a single variable x of the type f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The equation f of x equals ax squared plus bx plus c is called the general form of the quadratic equation, but are also referred to by some textbooks as the standard form. In this video, we referred to it as the general form of a quadratic equation. The equation f of x equals ax squared plus bx plus c is called the general form of the quadratic function, but the term function conveys a different meaning from the term equation. The term function implies that for every value of x, there is exactly one value of y. And all of these values when plotted will result in a U-shaped curve called a parabola. But we will study parabolas in later videos. Let's take a look at what is meant by the following definition we've got. For example, if we have y equals 2x squared plus 4x plus 5, then we can assign different values for x in the equation. If we have x equals 1, by substituting 1 to all x in the equation we find that y equals 11. When x equals 2, y equals 21. By repeating the same procedure, we can compile many values of x and y as shown. We can then plot these points, and the resulting parabola is shown in the figure. Of course, we need many more points than are shown here to construct a smoother curve of a parabola. So here we see that for every value of x, there exists one value of y as stated in our definition of a function earlier in the discussion. But in this video, we are concerned more about the quadratic equation rather than the quadratic function. By quadratic equation, we mean that we are only concerned about the set of solutions to the given equation, which in this case, the 2x squared plus 4x plus 5 equation. To transform the quadratic function into a quadratic equation, all we need to do is let y equals 0. We can then find a solution to the equation using different methods which we will discuss later on in this video. But for the sake of our current discussion, we will try to find the solution to the given quadratic equation by completing the square. So the given quadratic equation has no real root since the solution involved a square root of a negative number. So let's try another quadratic equation, and this time with a solution of the real numbers. So now we have x equals 1 and x equals -7 as a solution. Now let's take a look at what the graph of this quadratic function looks like. Here we see that what we called a solution is nothing but the x-intercept when y equals 0. The x-intercept is the point of intersection when the parabola crosses the x-axis. Now let's compare both of the graphs of quadratic functions that we have in this discussion. Here we can see that the graph on the left crosses the x-axis at 1 and -7, which is the solution to the equation. While on the right, the graph does not cross the x-axis and has no real solution. Now let's discuss different methods of finding solutions to a quadratic equation. But before we begin, we will take a look at two special types of quadratic equations. Number 1, those that do not contain the x term and can be written as x squared minus c, where c is a non-negative real number. Number 2, those that can be written as x squared minus bx minus 0, or those that do not have a constant term c. In type 1, the solution to the equation can easily be found by taking the square root of c as shown. In type 2, the solution to the equation can be found by factoring out x. Methods of finding solutions to quadratic equations with three terms of the form ax squared plus bx plus c. The first solution is by factoring. The second solution is by completing the square. The third solution is by using the quadratic formula. Let's take some examples. If we have x squared minus 2x minus 15 equals 0, we can factor it by first finding two numbers which are the factors of 15. And when added together equals -2. So that the factors of the equation are x minus 5 and x plus 3. And the solutions are x equals 5 and x equals -3. Or we can use the method completing the square to solve the equation. First, we transpose 15 to the right side of the equation, changing its sign from negative to positive. Then we complete the square on the left side by adding the square of half of the x coefficient. Then we add the same quantity to the other side of the equation. Now the left side is a perfect square which can be factored into. And we just add together the constants on the right side. Simplifying, we have and our solutions are x equals 5 and x equals -3. We can also use the quadratic formula to solve the same equation. All we need to do is substitute the values of the constants to the quadratic formula. Here we have a equals 1, b equals -2, and c equals -15. By simplifying, we have x equals -3 and x equals 5. So we can arrive at the same solution regardless of what method we used. But some are more convenient to use relative to a given equation than others. And we conclude our discussion here. More videos are coming regarding the details of methods of finding solutions to quadratic equations. Please support the channel by subscribing. Thank you.